In this video, we're going to talk about arrays in VBA. We're going to talk about how you can declare and initialize some static arrays and how you can declare, initialize and resize dynamic arrays within VBA. Now, the first question to answer is, well, what is an array? Best way to explain this is with something of an example. Let's head on over into the Visual Basic Editor. And we're going to add a module. I'm going to call it, let's use the F4 key. I'm just going to call it variables. Okay. So let's imagine a situation where you need to carry around a lot of variables of the same type. Within your code, you may need to define them, initialize them, and I don't know, print them out to the immediate window. I'm going to start with an example of a number of strings. So let's just say public my string 1 as string, public my string 2 string, and so we've got 3 strings here, and we'll create a subroutine, say print my strings. So these are all just public variables, and we'll start with just assigning some values. Let's say my string 1, and we'll say is just A, my string 2 AA, and so on. And then we want to print them to the immediate window. So let's say debug.print my string 1. Okay, so let's just quickly compile that, and we'll press play, and then we'll open up the immediate window, and we can see it's just printed the 3 strings to the immediate window. Now, my point here is that in order to do this, it required quite a bit of work. We needed 3 separate statements up at the top just to declare our strings. Then we needed 3 separate statements to add values to these strings, and then we needed 3 separate statements just to print out the value of these to the immediate window. Now, with an array, we have a nice convenient way of achieving all of this by treating these strings as elements of a single array. We only need 1 statement to declare the array. We can initialize the values using a loop over the elements of the array, and we can access elements just by knowing the index of the element in the array, and we can do things like print it out again by just using a nice loop over each of the elements of the array. So it gives us a nice convenient syntax to create and manage a group of related variables of the same type. Well, what is an array? Let's go back to Excel. And what I've got here is a nice little picture that I have found on the internet, which I think summarizes quite well what an array is. First of all, we declare it. And when we declare it, we give it a given size, a given number of dimensions. Now, you can have multiple dimensions, and we'll have a few examples later where we have 2 dimensions. But in this example here, we've got a picture of an array with just 1 dimension. We can see it has an index, and the index is a numbering system for the elements of the array. It starts at 0, although you can in some cases start at 1, and you can choose the kind of lower bound and upper bound that you want to use when you declare the array. In some cases it is chosen for you. So we've got 0, 1, 2 all the way up to 8. So that's a total of 9 elements. So the array length or size is 9. That's the size of that dimension. And for each element, we can hold a value. And this value can be anything from the given array variable type. In this case, it is an integer. Okay? And once we know the array name and the index, we can access these values nice and easily. Okay. Let's go over to the Visual Basic Editor and let's actually start creating these. I think a few concrete examples will really help to explain what they are and how they work. Let's add a module to our project. We'll go Insert, Module, and We'll call this module M static arrays. Close down the properties window. And we're going to create a subroutine. We'll say public sub create some arrays. Now to declare an array, we use the dim statement. Next we have the name of the array. Let's call this one my string array. And then we open some brackets and close some brackets. Within the brackets, we can declare it in two different ways. We can either provide the size or the length of each dimension. In this case, I'm going to create an array with a single dimension of length 5. So I'm just going to put the number 5 in there. And then we have a statement which says the type of variables that the array can hold. And in this case, we're going to say as string. Okay, so that will create an array of size, well actually it will be size 6, because it will include an array element of 0, 1, 2, 3, 4 and 5. So it's a little bit misleading. And the second way we can declare an array is using dim my, let's create a double this time, my double array. This time we're going to explicitly give the lower bound 0 and the upper bound, which is 4. So we use 0 to 4. We're going to have this as an array of doubles. Just line them up nicely. And finally, I'm going to create a two-dimensional array. So we're going to have dim my 2D array. And we're going to have 0 to 2. And then let's go from 1 to 8. So you can see in this case, we're going to have that as a long variable type. In this case, we're going to have two dimensions, and the second dimension for this array is going to have a lower bound of 1 and an upper bound of 8. Okay? So here we have declared the arrays and we have given them an explicit constant size. Once we do this, we cannot then go away and change the size of these arrays. They are static arrays. In a short while, we'll talk about dynamic arrays, but it's always easier to start with static arrays. Let's actually put some values into some of these arrays. I'm going to use a loop to do this. So I'm going to use dim array counter as long. And we're going to use a for loop for array counter and lower bound my string array. So the L-bound function takes an array as an input, and as a second argument it takes the dimension. So in this case dimension 1, although you can leave this off and it defaults to dimension 1. I'm going to say to U-bound my string array, again dimension 1, and the L-bound and U-bound function, what they return is the index of the lower bound and upper bound of the array. So using these two, we can nice and easily construct a for loop that steps over each element of our array. Next, array counter. And then to actually access the elements of the array, we use my string array, and we're going to use array counter and assign a value. Let's use the string function, and we'll say array counter with the letter A. So the string function will create a string of length array counter with a character or string A. So it'll just repeat the letter A array counter times. Okay, so that will initialize the elements of our array. Let's do something similar with our double array. So here I've created a for loop which will step over the double array. In this case I haven't used the dimension argument for L bound and upper bound, so that will default to the first dimension. It only has one dimension. I've also used a function rand between, which is defined down at the bottom here, and that will just create a random number between the lower bound and the upper bound. Okay. And finally, let's have an example of how to construct a for loop that steps over each dimension and each element of a two-dimensional array. So here we're going to need two separate counters, one for what I'm going to call the row and one for what I'm going to call the column. Actually, it's just dimension 1 and dimension 2, but we'll call it row and column, since in a separate video I'll talk about how you can map these to arrange in a worksheet where the row and column do actually make sense. So it's useful to think of it that way. So dim row counter as long, dim col counter as long. Then we'll construct our loop for row counter, and then inside this loop we're going to have a second loop. So I'm going to say for col counter equals So you notice here when I've used the L-bound function and the U-bound function, I've used dimension 2. So we are counting from, in this case, an index of 1 to an index of 8. Okay. In the outer loop, we will be counting from an index of 0 to an index of 2, because that is the lower bound and upper bound of the first dimension. And what we're going to do here is, again, we're going to use the rand between function, and we're just going to convert it to a long. So we've got my 2D array, and the way we access elements to set their values and obtain their values is just by using a comma separated list with each dimension and the index of each dimension that you want to get hold of. So in this case it's row counter and then col counter. I'm going to say convert to long the rand between. I'm going to say just row counter and col counter. Okay, so let's compile that code and let's actually put a few breakpoints in here and step through our code just to see how this works in creating these arrays. So I'll put a breakpoint here. So where the arrays have been created but nothing has been assigned to the values. We'll put one here so that the two one-dimensional arrays have been initialized with values, but the two-dimensional array hasn't. And then we'll put one just before we end the subroutine where everything has had values assigned to it. Let's click on the play button. So we've stopped here just before this for loop starts to execute. Let's open up the locals window. So view, locals window. We can see we've got 3 arrays here, and we can see the type. In the first case we've got a string from 0 to 5, second case double from 0 to 4, and in the third case we've got a long with 2 dimensions, 0 to 2 and then 1 to 8. So in the 2-dimensional array we can see 0, 1 and 2 as the first dimension, and in each case it goes from 1 down to 8 in the second dimension. So those are the index counter values, and that's the same for each of these 3 in the 2-dimensional array. We can see the values are just 0 to start with. For the string we've got 0 to 5 with just an empty string, and for the double we'll have zeros in there as well. Okay, let's move the execution down. Let's take away that breakpoint. We'll let it catch it just before we initialize the 2-dimensional array. And we should see here in the string array we've got values that have been initialized for each element. For the double array we've got some random values between the 2 ranges that we've specified. But for the 2-dimensional array it's still just empty. It's just got zeros in each element. Now let's run it through all the way to the end. just before we exit. And we'll see the two-dimensional array now has some random long integer values for each element of our two-dimensional array. Okay, so that's all I want to say about static arrays. Let's move on to dynamic arrays. We'll create a new module. So insert module, and let's give it a name. Let's say dynamic arrays. And in this case, the code that we're going to use will be very similar to in the static case. And what I'm not going to do to start with is assign any explicit upper bound or lower bound to the arrays when we declare them. Instead, I'm going to use a statement to resize the arrays later. So let's start with public sub create dynamic arrays, and we'll say dim my string array. We just open and close the bracket. We don't specify any values for the indices or the size. As string dim my double array as double, and dim my 2D array as long. So even in the 2D case, we just leave those brackets empty on the inside. And the next thing we're going to do is I'm just going to put a debug statement in here. We're going to use it for placing a breakpoint later. So then we're going to give these arrays a size. We use the redim statement to do this. So redim my string array, and I want to give it a upper bound of 5, so that will have values, or that will have indices from 0, 1, 2, 3, 4 and 5. We'll do it for my double array using the syntax of 0 to 4, and then we'll do it for my two-dimensional array. So redim my 2D array, we're going to go from 0 to 2 and then 1 to 8. So here we've created the sizes of the arrays in the same way as we have in the static case. You'll notice the difference a little later on when we bring the size back down and then increase it again, which is the key feature of dynamic arrays. So debug.print. Okay, and what I'm going to do is just copy and paste our code from the static case to actually assign some values to these. Let's just take this, we'll go copy, and we're just going to paste it in here. Okay, nice and quick and easy. So let's put in a debug print statement to say after initialization. So we should now have our arrays, they have the correct size and shape, and we have assigned values to the elements of the arrays. The next thing we're going to do is we're going to change the size of 2 of these arrays. We're going to do it in a different way for each. For the first one, we are going to keep hold of the values that are sitting in the elements of the array, and in the second case, we are not going to keep the values that are held in the elements of the array. We're going to use the same statement that we used to resize further up in our code. We're going to use redim, and we'll say my string array. Now when you redim your array, you have to, the lower bound has to be the same as the original lower bound. So in this case we had 0 to 5, so the lowest we can go for the lower bound is 0. You can't say have a redim it from 1 to something. and we're going to go from 0 to 3. So we've reduced the size from 0 to 5 to 0 to 3. We can't go from 1 to 3, that will throw a subscript out of range error. And the next thing we're going to do is we're going to add a preserve statement to this. So for those elements that are kept, it will keep their values within the array. And for those elements that we lose, it will just chop them off the end and throw them away. For the two-dimensional array, we're going to do readIm without a preserve. I'm going to do my 2D array, and we're going to go from 0 to 2, and then 1 to 5. Okay, so the next thing we're going to do is expand the size again. So increase the size. We're going to do readIm preserve my string array. We're going to go 0 to 5 again, and readIm my 2D array 0 to 2, 1 to 8, and then okay, so let's actually run this code through, put in some breakpoints and see what happens to the arrays at various points in the execution. We'll compile that and then click on play. Let's open up the locals window. You can see here we've got 3 arrays now, and they don't have any size, any dimension, they only have a type. If we run down to here after the first readIm, we now have a size, and we just have the default elements at the various, the default values of the various elements. So, same as before. Okay. Let's run it through to the point where we've initialized all the values. So now we've got some values in our arrays. We see my string has AA, and the first element is just an empty string. Okay, now we're going to redim the string to chop off some elements at the end. So we can see in the string array case, it's kept the first 0, 1, 2 and 3, and it's just gotten rid of elements 4 and 5. In the 2D array case, it has completely cleaned out each of the array elements and set them to 0, and it has also resized the array. So we've got 0, 1 and 2 as our first dimension, and we've got 1, 2, 3, 4 and 5 as our second dimension. So now we're going to grow these arrays again, increase their size. We can see now my string array has been increased back up to size 0 to 5, and 2 new elements that have been added to the end have the default values. In the 2D array case, it's just increased it from 1 to 8 in the second dimension, and everything just has 0 values there. Okay, so I'm going to stop the code execution there. Let's just run it through. At a very high level, that is arrays within VBA, what they are, how you can declare them, add values to the various elements of the array, and how you can access those values. And we've given you a nice way to loop over an array using the L-bound and upper bound functions. And lastly, we've talked about dynamic arrays and how you can shrink and grow the size of the dynamic array. And in each case, you can either keep the values that are already sitting in the array elements, or you can just get rid of them.